Good morning or afternoon, everybody. Welcome to Busbar Protection Testing webinar with Engineer Ahmed Abdul Wahab and Mohammed Ibrahim. My name is Jamila Radi and I will be the moderator for today's webinar. I would like to draw your attention to the microphone. As you can see on the control panel, it's put on mute by the moderator to ensure a silent environment for the benefit of all our participants. If you're facing trouble hearing us, please ensure that you select your preferred headset or speaker from the audio section as illustrated here. Later in the Q&A session, you can raise your hand and I will turn on your microphone to allow you to ask your question. Please note that this webinar will be recorded and we will stop the recording at the Q&A session. To ask questions throughout the session, please choose the question dedicated area as illustrated on this slide. We will try to answer as many questions during the webinar. However, in the case a question is not answered during the webinar, please note that it will be answered in a follow-up email. We will have some poll questions during the webinar that look like this. All you have to do is click on the answer. Sometimes poll questions may appear in separate window. If you face difficulties in showing or answering polls during the webinar, we recommend that you change the browser that you are using. Please make sure to download the presentation and the product brochures from the handouts section. Please take note that the contents of this presentation are Omicron's sole and exclusive intellectual property. If you wish to record, copy, or otherwise distribute said contents, please request prior written consent from Omicron. You should not post any webinar videos, accompanying file content, or links to them on any public platform, such as LinkedIn, YouTube, Facebook, Twitter, or any others. The recording will be sent to you in the follow-up email. This email will include a feedback form. We would appreciate your response to help us better serve your needs in the future. Finally, we're excited to announce the launch of the new LinkedIn Omicron MIA page. The page serves as a platform to share the latest MIA power system updates. And content you can expect is technical papers, case studies, and event updates and webinars in Arabic, English, French, and Turkish. We will share the link to our new page in the follow-up email. We kindly invite you to follow us and stay connected and updated. Thank you for joining us. Enjoy your webinar. I will now hand over to my colleague, Engineer Aditya, Area Sales Manager, Omicron MIA.
Thank you, Jamila. Welcome from my side to all the participants. Welcome again from my side to all the participants. I'm keeping my camera off to save some bandwidth, but let's have this session on busbar protection testing with Mohammed Ibrahim and Ahmed Abdul Wahab. Let me quickly introduce myself. I'm Aditya Taneja. I'm responsible for sales in some of the West African countries, and also I am handling circuit breakers and switchgear application as a specialist here at Omicron Electronics Middle East. Today I will be available in the background during the session taking your questions. Please put them in the chat and we will be replying to them accordingly. And at the end of the session, we will take a few of the questions for discussion with our speakers here. You can also contact me through my email or my mobile if in case you need any further information related to Omicron. Our speakers today, one of them is Mohammed Ibrahim. Mohammed is having more than 17 years of experience in the field, and he's having around 12 years of experience in GCC itself. He has been working with Omicron since July 2015 and provides technical and application support for our products to customers here. He's also conducting theoretical and practical sessions for for our customers for sharing knowledge, and also he helps in troubleshooting technical problems for our customers. He also develops application notes and technical papers for various applications. From his educational background, he has done BSc in electrical engineering in 2002, and he has completed his high postgraduate studies in 2007. You can also directly contact him on his email and his mobile for any further discussion on protection testing or any application which you may be needing. Then we have our co-speaker as Ahmed Abdul Wahab. He's a application engineer focusing on protection. He has started with Omicron since 2018, and before that he was working for engineering services. Before that he was working with Siemens for 13 years as in the field of electrical generation, transmission, and distribution projects. You can also contact him on his email and his mobile number. A little bit about Omicron. We are based out of Bahrain right now, but globally Omicron has 25 offices, and we are serving customers in more than 160 countries at the moment. And customer value is our key focus, and we do that by providing innovative solutions, extraordinary support, and through shared knowledge. We do that by innovating a lot of products and applications, such as Busbar testing, which is shown in this picture. And we are going to talk about this today in detail as well. So there is a lot of innovation which goes into our products, which finally helps customer test their system to make sure that their network performs reliably. We also have more than 50 highly qualified engineers providing technical support 24/7. So whenever you call our technical support numbers, you will meet one of our engineers who would swiftly respond to your technical needs. So that's an extraordinary support that we provide. And finally, we also have international presence and international community, which is a mix of a lot of experts from the field, which are more than happy to share knowledge. You can also log into our customer portal or log into our webinars like this one to tap into the knowledge. So with that, I would leave you with Mohammed Ibrahim and Ahmed Abdul Wahab, and enjoy your session.
Thank you very much, Jamila and Aditya, for the great introduction. And welcome everyone, and we are very happy to have you with us today. We will do our best to show you how you can test your circuit breaker by using CMC and our application. Let's start. I will share my screen. Actually, our webinar will be based on two parts. Part number one will be theoretical, by short description, short details about Busbar, and after that we will do two practical examples. One we will use relation test, and the other one we will use test universe. For sure, I'm very happy to have Ahmed Abdul Wahab with me today. How are you, Wahab?
Thanks, Hamad. Thanks for the introduction for Jamila and Aditya. And I hope today you will enjoy our session about the Busbar protection, theoretical part and the practical part. And so we can start?
Yeah, sure. Yeah, let's start. For sure, our main topic today is the Busbar protection testing by CMC. For sure, it's the main focus. And to start this, we need to give some information about the Busbar system, about the different schemes in the Busbar.
Yes. So exactly, the Busbar protection, from the point of view of electricity, it's a very simple protection. It depends on Kirchhoff current law. And Kirchhoff current law said that all currents enter any protected zone should leave it, or the total summation for a current in plus the summation of the current out should equal to 0. was taking into consideration the directionality that the current into a protected zone should be positive and the current leaving the protected zone should be negative. But since the principle of the protection is very simple, so we should understand what are the reasons for the busbar protection to operate, or what is the reason of the busbar protection faulty. The main reason that the busbar, maybe by mistake you connect an earth switch for the busbar protection, or there is a mechanical failure for any of the insulator that carry the busbar, so it will give a path for the current to flow into the earth. So this is the most frequent fault. It's a human mistake or an electrical failure.
It cause a huge damage because it's very close to the main busbar.
Yes.
And this will be a big failure and loss of energy.
And exactly the fault resistance, and there will be no fault resistance, or there is no impedance to limit the current.
The short circuit level would be very high.
Yes. So, and actually this is the point when you are talking about the short circuit level, or you are saying that the short circuit level capacity in this substation is, for example, 40 kilo amp. This is the withstand current for the busbar protection, not for the equipment, because the highest fault in the substation will be mainly on the busbar. And the busbar protection, it's mainly applied in the transmission network, and also it can be helpful for the distribution or the sub-transmission network. In the distribution, differential protection.
We don't forget that it's costly system.
Yes,
it's not complicated. It's basic, but it requires more experience to deal with this application.
That's why the main focus for the busbar protection will be in the transmission network, not similar to the distribution, because we need to pick some significant application in the distribution network to apply the busbar protection, mainly in the important distribution network or distribution substation, or a gas insulated substation, which you are afraid that you can damage the busbar due to the switchgear due to busbar fault protection, or also for less important network, you can use the reverse interlocking scheme to avoid the fault on the busbar. So in general, you need to know exactly what is the reason and what is the importance of the busbar protection. Now we need
to know types of the busbar. We mentioned already here low impedance and high impedance.
Yes.
Maybe we can give more information about the difference between low impedance and high impedance.
In the next slide, we will talk about the low impedance busbar protection. You can see we have a single busbar, we have N feeders, and we said that based on the Kirchhoff current law that the summation of all current in should equal to all current out. So we define two parameters. The first parameter is the operating current or the differential current, or we can say the trimming current. The second parameter is, we can say, the restraint current.
Sometimes restraint, sometimes bias.
Yes.
Both are equal.
It depends on the relay. It depends on the relay manufacturer. You can see different names. So operating current, differential current, or restraint current and bias current. But we can see here from the equation itself that the operating current is equal to the absolute value of the vectorial summation for all currents in and out. So based on Kirchhoff current law, if you have a stable condition, that one current in and the same current out, so in general the operating current will be zero.
Again, here we need to highlight that the restraint equation or the bias equation, it is not the same for all manufacturers, but for sure the differential is typically the same everywhere.
Exactly. So it depends on the best practice for the restraint current. Some of them, they are saying it's a maximum current for all feeders. Some of them, they are saying that's the maximum current, the summation of all currents divided by 2, or some of them, they are taking also the angle between the two currents to have directionality in the restraint current. So you need to look at the relay manual to understand exactly and know what are the equation of the restraint. In our test universe, we are supporting different types of the restraint. Yes, and you need to know exactly, as we said, go back to the relay manual, see what is the exact restraint current, and try to pick it from the equivalent values or equivalent equations from the advanced differential module. Let us look at the right side. What is the relation between the operating current and the differential current? We can say it's a scalar relationship. So you have two axes. The first axis, we can call it the operating current, which is a vertical axis, and the horizontal axis, we call it the restraint current. And we have IP, which is the minimum operating current, or I busbar, or whatever you would like to have. If you draw a very simple equation, in case of we have I restraint equal to 0, so the minimum operating current will be the I base.
Maybe you need to select
again, yes. So in case if we have restraint current equal to 0, so here we can go to the equation and we will cancel this part, and so the I operating should be equal more than the minimum operating current.
At this point, we can consider it as a pickup and the drop-off. It's only to check the sensitivity of the bus bar. It can be done by random test module.
Exactly. And also the idea behind having IP or the minimum operating current to cover the normal error in our system, like the CT error, like the CT ratio error in all units, because not every CT in the network has the same accuracy. So you have a minimum differential current, which is normal. So you are just having the IP or the minimum operating current to overcome this error. Then it's a linear relationship between the I operating and I restraint. Very, very simple relationship, and with a slope K. So as long as the I restraint current increase, the I operating will be increased as well, to avoid the mal-operation for so many reasons we can say about that. As the loading increase, so the CT ratio error will increase, the CT saturation may affect as well, so that will increase the operating current to avoid that.
Yeah, and this we can test it by operating characteristic test module as well with advanced differential.
That is our part from the test universe that we have. As we said, we have two practical sessions. The first session is relay sim test to check the overall scheme. The second session or the second section is to test the differential characteristic using advanced differential module with the test universe. Now let's go to the high impedance. The high impedance is a little bit complicated from the low impedance, and it is mainly used with the old scheme, 2 busbar or breaker-and-a-half scheme. The idea of the high impedance is similar for the low impedance, but we are collecting all current and end
to pass through a resistance and convert it to a voltage. At that moment, our setting instead of current will be voltage.
Very, very simple. We are applying KCL. We are submitting all current, and in every CT we have RCT, which we can call it the CT current or the CT resistance on the CT winding, and we have RL. This is also with the leads. So we are putting a resistance on every CT, secondary CT wiring plus the RD, which is available in your system, and at the end we have RS and R shunt. The R series, which is a series resistance, just to limit the current flow inside the relay, and the shunt resistance to have a certain value of the current to develop a voltage across the comparator. And the end, we have a varistor, which is called metro cell. This is to avoid the over voltage to protect the relay itself in case if you have a huge current flowing in the shunt resistance. So it's a very, very simple scheme, very, very problematic, by the way. Simple, it doesn't mean that it is very easy to use, but it's a problematic because as long as you have so many parameters and so many equipments in the scheme itself, so the failure of any of them.
We need also to consider the same class of the CT, the same ratio.
Yeah, the calculation is huge in the busbar.
That's why for the extension for the substation, especially for the old substation, it's a little bit challenge to have the same type of the CT and the same CT ratio.
Exactly. When you are doing CT dimensioning, you have to put in your consideration that all CTs, both of them should have at least a certain range of the saturation level, knee voltage and knee current. Not only that, switching from a busbar A to busbar B, from busbar 1 to busbar B.
Maybe it's coming with the next slide.
With the next slide, that if you can see that I need, for example, my feeder is connecting to busbar 1 and I need to switch to busbar 2. So what does it mean? I need to change the current from comparator delta I1 to a comparator delta I2. How can I do that? With a bistable relay, take the position of the disconnector. This is what we call it isolated replica. So in case of the disconnector 1 is closer to the bistable, 1 will be picked up and it will divert the current to delta I1 comparator. But in case if we have that the feeder is in busbar number 2, so you can see here, for example, 2 is open and 1's closed. So I need to switch the current from comparator 1 to comparator 2. So switching this current from busbar 1 to busbar 2 or from comparator 1 to comparator 2, this is very risky because it's related to current flow in a mechanical part. If this mechanical part is stuck at a certain position, so the CT circuit will be open. So you will have two cases or two conditions. or two circumstances. The first one, that the city secondary circuit is open, which you can develop a huge voltage and it can burn the complete scheme, which that's why we have the varistor to avoid that. Second part is that the mal-operation, that the busbar maybe will detect the differential current, even the system itself is stable because of the opening of the city circuit. So now you should differentiate between the high impedance and the low impedance. For my experience, I work in Saudi Arabia. The whole 380 kV substation was on high impedance, and now they are changing to the low impedance due to the problem.
Actually, honestly, from my experience, it's a big debate. Which one is better? Which one is more stable?
Yes.
And a lot of reasons. And you know, we don't have a system which is 100% perfect for sure. Each one has a weak point, strong point against the other, and the decision can be taken by the customer. For sure, he is free to use any of both techniques. Also, maybe we need to highlight here, we have the check zone, the discrimination zone.
Yes.
What does it mean by check zone, for example?
The check zone, it's just from its name, it's a check zone or a complementary zone. What does it mean, a complementary? Due to the mistakes what happened, and due to the as we said, the opening of the city circuit during switching from busbar 1 to busbar 2, any mal-operation can happen. So we can say in general, due to the errors in the isolated replica, I need someone who is monitoring that. Yes, there is a real trip happen, there is a busbar fault, and at the end, the decision should be accumulated together. The bus zone and the check zone, both of them should decide there is a busbar fault, and at the end, I should give the trip command. So in some cases, the overall zone, which you can see here, it's the outside zone. This is a complete check zone, and it is gathering the whole current in and out, and it is deciding that there is an
can say in general Kirchhoff's law.
Yes.
It's in equal to out,
yes,
without respect of any
current replica or isolated
yes,
replica.
Yes, it's complete. It's complete entire connection of the busbar. All current in must be equal to current out. If not, then it has a detection of fault internally.
Exactly.
But we still not define where exactly, especially if we have a big substation, double bus bar, which we have also bus coupler and bus section. Which section we need to isolate? This will be done by the selective zone. Maybe here also we can show this is a kind of two of them. We have a check zone and we have a discrimination or the selective zone, and both of them together should be ended.
Yes, exactly.
To issue the trip command.
Just let's go to what does it mean? Ending, it means that you have a trip contact from check zone, from busbar zone 1, and a trip contact from busbar zone 2, and all of them, both of them are in series with the contact from the check zone. So if a busbar 1 trip and check zone trip, so it means there will be a trip command on a busbar 1, or if a busbar 2 trip. So this is a discrimination. Both of them are combined together, ended because they are in series. Then you have to define that where the fault isn't in busbar 1, isn't in the busbar 2. This is in the high impedance scheme. So numerically, also selective measurement. So we can proceed, Muhammad.
Yeah. Don't forget also the breaker fail or breaker failure rule in the busbar protection. Maybe we can say from our experience, maybe especially in Saudi Arabia, we have two different schemes. One is we have trip and retrip.
Yes.
What is the difference in the schemes? One type is two will issue at the same time for trip coil 1, trip coil 2 at the same time. If not, the second stage will be initiating the busbar to trip, even it's not a busbar fault.
Exactly.
But we have a fault on the line and we cannot isolate. It will be considered as a part of the busbar, even if it's outside, then you have to isolate the source of that fault. The other one is only one time. We don't have two stages. And this, if it is one, it should be delayed after some time. If we have two stages, one will be instantaneously with a trip command, and after that a delay to initiate the circuit breaker to trip. The second scheme is only one time after a delay time to around 150 milliseconds. 100 to 150 milliseconds, and immediately once it's initiated, it will directly initiate the bus bar. No need to retrip again the second query process.
Exactly.
Okay, maybe here we can give the two examples of two schemes, centralized and decentralized. From the name of decentralized, it has central units, different bay units, and connected all together to the central unit, which it can give the decision of tripping or not. Centralized, it's I think all the time when I heard about the centralized unit, I'm thinking in check zone as one unit which connected to all cities. And this is the second one. Maybe I can give more details about each one. I will select here the centralized unit and we'll give one example. Here, select. Yes, here. This is how it will look like. We have a centralized unit or central unit, and this central unit connected to all bay units. And mostly we are using fiber optic in communication. This is the latest technology, using the fiber to send the local measurement to the central unit, which will do the calculation and the processing to check is it a fault or it is not a fault. And this is how it's looked like. Each bay unit will be connected to the isolator, and also it will connect to the CT as input for the analog input. Now we will discuss about the central unit, and mostly we will use this example in our practical example or our practical application. As you know, in the training room, it's difficult to have a kind of decentralized. We have the centralized bus bar from different manufacturers, as you can see on our background. About the centralized, we have, as you can see here, we don't have BCU. We don't have the big control unit at all. We have only central unit connected to
current from all fields.
Maybe this is the biggest challenge because it's difficult to have a relay to be connected with many feeders because analog input channels are not enough to withstand all. I saw in some manufacturers they are make it in sections like phases. For example, one for phase A, one for phase B, one for phase C. Some other nodes they have more than one relay, and they are considering the overlapping to overcome the whole system. But also centralized busbar protection may use, I think, for the less number of the feeders. If you have a huge substation at that moment, I think it's a big challenge to use centralized busbar protection.
And actually, this is the main scheme for the medium voltage switchgear because it's a single busbar.
Yeah.
So as I saw in my experience, that in the medium voltage switchgear up to 33 kilovolt, they are using the centralized protection and their phase. So, for example, if you have a relay that have 20, 25 inputs, so you will make it one for phase A, one for, as you said, one for phase A, phase B, phase C, and at the end, all of them, they are gathered together to trip the circuit breaker itself. So it's little bit, you will spend more money, but you will protect it as better.
And it's less problem compared to the decentralized because of no fiber optic, no communication error, only just one unit will have all current in and all the status of the disconnector circuit breaker connected as a binary.
Exactly.
A huge number of wires, many wires to be connected, but maybe with the digital solution,
it's just an Ethernet cable.
It will be very easy. I have an example about that. You will see. I will test the whole system with only Ethernet cable to be connected. No more. It's not the main topic for today for digital solution, but I will use the concept of full digital to simulate busbar for feeders. Let's go back. We have here, I think you already explained that before, but maybe here with more explanation about the trip area, about the blocking area, and what about the maximum line?
Yeah. So as we said, it's a very simple relationship between two parameters. The first parameter is the I differential here. The second parameter is I bias. So the relationship between the differential current and the bias current is a scalar relationship. So there is no vector. So to draw such kind of a characteristics, we need to have two things. The first one is the I degrader, which we can call it the minimum differential current, and the slope, which is the blue area. But under the slope of the blue area, there is a blocking area. So what are the blocking area, or what should I have a blocking area? As we know that in any differential system or in any protection system, there is an error. So the first error, what we have is a CT error. The second one is a CT saturation error. So this is the main error what you have in your protection system. To avoid tripping or to avoid maloperation of your protection system due to this kind of errors, so we define or we introduce the blocking area. So now the blue line is my relay settings. The red line here is the maximum torque angle, or this is the maximum current can flow in case if we have an internal fault. Sorry. So if you have here a line, so this is substation A or a busbar, both of them are similar. If you have a busbar or a substation A and B, and you have current in from this direction and you have current in this direction, so what is the maximum fault current? The maximum fault current is 2I, and the maximum restraint current is 2I. So the relationship between, if you draw a relationship between I differential equal to I and I restraint equal to I, is a line passing through the origin and its slope is 45 degrees. So this is what we call the maximum torque angle or the maximum fault angle. By default or by electricity, the tripping area where we have an internal fault is slightly in between the tripping between the actual relay setting, which is the blue line, and the maximum trip. You will never have a fault here. Sure. Because you will never.
Mathematically, it's impossible.
Yes, mathematically, because there will be a source of hidden current, you don't see it, so the slope is higher than 1. But by mathematics, so you shouldn't have a trip fault higher than this. And even in our test universe, if you try to simulate a fault higher than 45 degrees, it will give you this is wrong. There is a wrong testing point or not valid testing point. So this is in general the slope K based on your relay settings or based on your system calculation. You need to calculate everything. Then you need to decide the K, and when you are deciding the K, you need to expect that internal fault should be here in this area between the maximum fault.
To make it bigger or smaller.
Yeah, smaller or bigger. So based on your calculation, if you reduce the slope, so it will be bigger. If you increase the slope near to 1, so it will be smaller. This is in general about the busbar selective measurement, and later on we can see about the busbar tripping or the check zone.
And as we mentioned before, we have the busbar selective measurement, which is sometimes we call the discrimination zone, yes, which has here busbar 1, busbar 2 separate with different color, red and blue, and both of them will be acting with the same slope differently.
Exactly.
And now we will talk about the same everything, but now
for the check zone.
Check zone. As we can see here, we have the gray box. It is a container for the entire busbar to check current in equal to current out or not, to detect is there any fault in or no, to start the busbar protection. And as we agreed, it should be ending together with the discrimination or the selective zone to issue a trip. Maybe here we can talk about the directional current comparison, phase force comparison we have, if we have an internal fault or stable or external fault.
Yes, exactly. It's just, we can say, as a backup way for measurement or a backup protection to avoid the maloperation. As all of us know that if I have an internal fault, external fault or a healthy, so the current will in should equal to current out. This is normal. In current equal, even the fault is outside the busbar. There is an external fault outside the busbar or a healthy. So you will see that both current 1 and 2 are out of phase. because we assume that the current in is a positive, the current in is negative. So if you would like to say -1 in electricity, it means that 1 with angle 180. So 1 with angle 0 is 1, 1 with angle 180 is -1. The same if you have an internal pole, both of them very close to each other.
Yeah, this is a very good answer. Close to each other, not 0 degree between both of them, because it's difficult to have both of them in 0 degree. But it will, if you make the equation, you will get a value of the differential.
Yes, as you can see here, both of them are very close to each other. The angle almost 0, so that we will have a differential curve.
Maybe this is one of the application example. As we can see, we can test any kind of topology, double bus bar, single breaker, as we can see with a bus coupler. This can be done and tested by relay sim test easily, but also with test universe, but we have to divide it into small sections to have one reference feeder, one injected feeder, or the feeder and the test, to do the test for that. Another scheme, which I will use it actually, this is what we will use it today. We will have single bus bar or have with bus section, and 4 outgoing feeder or 4 feeder in this scheme. This is what we will test today. And actually here I will have ABB RIP 670 as a centralized system. And this is from the relay manual. This is the example which I really applied here. Maybe in future, in advanced level, we will do some webinars about different protection scheme like double bus bar, single breaker, or even double bus bar, double circuit breaker, or 1.5 in the upcoming webinars. Please follow up with us. Here, the first practical example will be the lesson test, as we mentioned. I prefer always to open the software, start to explain point by point. At that moment, I would like to switch on CMC. And I will stop sharing, and I will share the software directly. Okay, as you can see now, this is the relay sim test software. I opened already the example. As you can see here, we have 4 sections. Section number 1 is called documentation. It's related to the data and comment that you need to make it in the test report. And after that, the section of the test report, you need to select or deselect the data which you need to print it out or to export. And also you are able to insert your company logo here in the test report. The second part, which is the most important, is the system under test. As you can see here in the relay sim test, you need to draw the topology. You can easily use the library to do the drawing, to do the topology. It should be typically as it is the same in your substation. Also, you can use one example from the template, and you can modify it. You are free to do it. The data which is required here is very less compared to the conventional testing. You need only to select the CT or any element, and once you select it, you can find here in this side the CT ratio available. Sometimes in an advanced application, which I like it a lot, I need to simulate the saturation. And how to do it? It's not difficult at all. Only just you need to enter the data of the CT. If you have a test report from the CT analyzer, which will be much easier, you can select the test report from here. And maybe I have one. Don't have it right now, but okay. If you have a test report, you can enter it, and automatically it will be imported, which will have also, it will have CT saturation.
The characteristics of
yes. If you don't, you can make it ideal, but you will lose one of the benefits of relay synthesis. After that one, very easy. This is a centralized relay. It is connected to all CTs and the circuit breakers as well. And also, you need to define here in the third section about the hardware configuration, as we agreed before, Ohm's law, something similar. We have here the system under test, then we have the hardware configuration. For the hardware configuration, double click, you will find here that the analog channel, analog output to be connected. But here, luckily, I have a full digital substation or a full digital application. I don't need any analog physical current or voltage. It will be sample value to be digital form. And also, you can also use a binary input and binary output. For the binary input and output, actually, I'm using also ghost messages and control for the controlling the disconnector and the circuit breaker instead of wiring. If you have conventional substation, no problem. Instead of the full digital, you need to connect this to the binary input, and you can define the binary input and output as well. The last section, which is also the most important one, is the test scenarios. In the test scenarios, here you are free to add any kind of test scenarios, test situations that you need to apply. Here, by default, I use two scenarios. One scenario is stability against external fault or even with the normal condition. For example, here I have a stable and load flow. I don't have any faults, and the system must be stable. Yeah. The system must be stable. Even I can also change the time of the injection. Maybe I put here 20 seconds, which is too long, but let's do it 2 seconds only. You can play with all of that. Here, this is the current is normal, voltage is normal for the 4 feeders, as you can see.
There is a question come to my mind, Ahmed, yes. Before we start testing. Can you go back to the system under or the configuration?
Sure. But here, as you can see, if the circuit breaker is open, you will find the current is 0 for that feeder. Only that one I will explain, and I will go back. Sorry. Here I have one feeder, circuit breaker is open. What does it mean? No current. Anything here of this element position will be related directly to the current value and voltage value based on that. If we have a breaker open, then no voltage, no current. Here I'm not connecting the VT, I'm connecting only CT. Then I have CT for feeder 1, for feeder 2, no, feeder 3, and for the fourth feeder. Okay, all here the feedback will coming by ghost message. Again, your question I will go back to power system. Yes.
No, for the configuration, I mean.
Okay.
Yeah. For the configuration, if I have now 2 or 3 CTs,
yeah,
I need to synchronize between them.
You mean 1.5, for example?
1.5, or I'm not using a fully digital. I have a 5 or 6 bay units, and I want to inject all of them simultaneously.
Yes.
With a different.
A very good question, really. I have. You can use here multiple CMCs to control the by one software, and this is one of big advantage. Yani it's a luxury solution, to be honest. And for example, I have 24 feeders busbar system. Can I test it all in one? Yes. I can use one software, which is a relay synthesis, to control each one. For example, if I have 356, two current, 2 system output, which is 6 current output, can cover 2 feeders. Mm-hmm. Then I can use 12 CMCs to cover all feeders without respect of this bus coupler. Maybe this is added one. And those 12 CMCs can be controlled by one software, which is relay synthesis. And you can do the test completely. And instead of 1 week, you can do it within 1 hour and make sure that everything is working fine.
How can we synchronize between the two CMCs?
This is another good question. Actually, I have many techniques, not only one. The first technique, maybe I have here a PTB time source. I'm sure the camera is on. Yes, I have a PTB time source. This through a PTB switch connected to all CMCs. Then it will synchronize.
Can I show it? Yes.
Yeah, just 1 minute. Maybe yes. I have.
This is the PTB.
Yes. and this is connected to a BTB switch, special switch to transfer the signal. This is the first scenario. The second scenario is my substation has its own BTB time synchronized, which is already used now in all relays. All modern relays, you will see a BTB as a time source. At that moment, you don't need this source, or you don't need also the BTB switch, because you can use the time synchronized source from the substation itself. The third scenario is, and this is I like it a lot, that the CMC with net 2 with relays themselves, you can use the CMC itself as a ground master clock source. What does it mean? That the master CMC will give the time signal for other CMC. At that moment, you don't need time supply because, or time source, because your CMC can do it. That is you.
So regarding the synchronizing between two CMCs without GPS or without a
time source. One is master, one is slave.
Where can I get it?
Okay, we have two Ethernet ports. You can connect the Ethernet port 1, for example, to control the CMC. Ethernet 2 from one relay to from one CMC to the other CMC, and here you can use, as you can see, local sync. Okay. Then you will select this CMC as a local sync. It will be a time supply for the grand clock master for the other CMC. That's great. Any other question?
Thank you.
Okay. Coming back here to the test scenarios, as I mentioned already, you are able to create different test scenarios. Some of it, maybe it's like boost module. What does it mean by boost module? It gives you an instruction that, for example, make sure that wiring check is done before starting. And here, for example, I can create injected or injection scenario like stable without any fault, or something also very, very important, which is fault outside the zone of protected area, and which also must be, as you can see here, kind of faults. And also we have different fault type. You are able to play with the fault type easily here. This is line to neutral. This is three-phase fault. Here, this is the external fault. If I click here, this is the fault here is external outside the zone. You have to get the trip command for sure. If you sorry, you must not get any trip command because your system is stable. It's external fault. You can do that in different location for sure, and also you can simulate external breaker fail. If you have a breaker fail, also you need to make an external fault, and this fault will continue and get initiation from the breaker fail to the busbar to issue the trip. This is one of the examples that you can use. And luckily here also we have something like breaker fail. If you will select the circuit breaker, you can find automatically assign the breaker fail for this breaker, for example, or maybe this is the external. I will select this circuit breaker, and if you select the circuit breaker, you have here icon, and this icon you can add breaker event also when it will open, when it's closed, and you can also make it as a breaker fail to continue closed without open, even this a trip. Once we finish this, here maybe I also did additional one with different circuit breaker positions for each feeder. I don't need also to take more time because the time is limited, but what I need to show you that you can also enable, you are able to play with this connector's position and circuit breaker when it can open, when it will close, to check the all possibility of the fault with your system. And don't forget also, you can also add fault resistance, filter histogram, and also this is something very amazing, which is the inception angle you have, especially if you are doing it with CT data. Yes. Inception angle will affect a lot of the fault, of the peak of the fault that will maybe push the CT based on the current value to be in partial saturation or fully saturation. This can be simulated easily by relay test. Let's jump to fault criteria or the fault issue and getting the feedback from the busbar. Here I have a phase to ground fault. here on the bus bar itself. I can play with the fault location for sure. I can add many scenarios with very simple steps. Maybe I can here show only as an example. I know that the time is limited, but let's see. Here, for example, I can select many parameter here, for example, with different inception angle or maybe fault resistance. If I, for example, I will select inception angle, I will choose. At that moment, it will open new column that you can add multiple, many points, and I can add those test points and all of that. Okay, I will skip this one now, but I need to show you, yes, available. Also, you can change the fault loop from here, or even doing the creation very easily. Something I like it a lot, maybe I didn't mention here. If I would like to get the measurement of that city, I need to check, then Bennett will be here. Also, based on the selection, it will give you the value of that. Also, you can add multiple measurements. You can do that everywhere. For example, the feed, you can get it here for the bus bar itself. You can get it, and you can add multiple measurements to study the system more. Maybe also a good news for relation tester I have, it doesn't require license, only license to make it real with the communication with the CMC. But you can do this offline. At least you can understand the fault circuit level that you have and the expected fault current before starting it with the device.
So I can use it as a fault calculator.
Yes, but it's a good idea to study your system if you are a maintenance or protection engineer by using relation test offline. And once you have a probe or test file, you can connect to CMC to generate that signal to be injected into the relay to perform the full test of your protection system.
So we can say that in case if I'm a protection engineering department, for example, I can simulate any kind of fault, then export it in a ComTrade file.
This is a good question, really, but this is required a license. If I have a license like what I have it now, I can export the ComTrade, as you can see. A ComTrade, this ComTrade data will be in a ComTrade file, which you can use it as a advanced translate as a playback later on.
Exactly. And we had already a webinar before regarding
yes to playback this. Yes, but I prefer always to have this inside the relation test because you will inject that signal to the relay. This is better than playback. Why? Because playback is only one ComTrade file. But here you have different cases. Yes, you can make even hundreds of different test scenarios to complete the test within a few minutes or within the limited time.
Yeah, actually, it is an option for who need it. Just to highlight it, that you can export the fault as a ComTrade file.
Yeah.
With a different sampling rate, by the way, you can make it very high sampling rate. You can make it up to 10 kilohertz sampling rate. So it is based on your scheme or even your fault.
Even also in the zone fault, we can simulate it very easy. The end zone fault, if you have a fault between the CT and circuit breaker, if you don't have you have it overlapped by the feeder, not by the bus bar, it's also considered you can edit it very easily, as you can see here. And you can simulate it very easy to do the test. Due to the time, maybe I will start now to show our customers how we can execute this very easily by only one button, which is here. I selected test cases, then execute. Because it's digital, if I would like to start this digital, it will check that this is a very good thing for safety. No duplicate. If you are working in a live substation, it will check no duplicate or not. This is very important for safety because it can lead to maltrip, and this is very dangerous. Here, luckily, with the addition tool, we have a simulation flag. You make it here no, it means it's real. If you need to test it, even it is online in our giant substation, you can easily do it with a simulation flag. The relay itself will be under test, and it will understand that sample value with the simulation flag under test, and they will give the thread with the simulation flag, which will not accepted by the VCU to thread, but it will be accepted by the test kit to receive. Then this is a new era of testing. during the live substation.
And if you are interested about knowing about IEC section 150 stuff, you can contact us.
Yes, contact us. We would be very happy to do a dedicated session for you. Okay, once it checked the whole network that we don't have duplicates, it tell me, yeah, I can continue now. And let's see, automatically it will start to check also the ghost messages. And once it's not duplicated, it will come here and it will continue. But here I did the 1 point. I selected only this test case I have. I would like to select all test cases, not only here, for example, here. Yes,
to mark all.
Exactly, here mark all, and now it will do 1 by 1. The good thing here that it will do Wang check, and I added this scenario with Wang check with a long time. So during the injection you have, I can read out the current value and voltage value if it's injecting voltage, but here I'm injecting current only. You can see here in each feeder the current which is injected simultaneously, that you make sure that you are injecting in your system without any problem. Started now stability. Stability should not have any trip. Maybe this, can you set the trip? Reset. If not, no problem, because in the trip condition, it will come here at I don't need to waste the time because the test universe we need some. Okay, here for stable, as you can see, maybe I will stop now and I will select one of the internal faults. Here, as you can see, infinity, no trip at all, no trip time. Something I liked a lot with the digital solution, that you have the status of all goose messages without wiring. Then you can analyze. Here, as you can see here, we have also infinity, no trip. To make sure, I will go down here. As you can see, I have this is circuit breaker status close, yeah, and no trip from any zone, nothing. You make sure that relay is stable even without checking the LED. Yeah. Here is the status. Maybe I will give the last example on the relay sim test. If I have a busbar fault, what is the expectation? It's a trip, and based on the which feeder it is.
And you can even take the feedback from the circuit breaker to simulate the circuit breaker.
Yes, exactly. Yes, and we will see even the current. Here now we got the trip, as you can see, very fast, 6.5 milliseconds. Imagine how fast it is.
Yes.
And after it's finished, you can see the ghost messages here. As you can see, all zones based on the faults. As you can see, different fault loop. And really, I like this solution, this approach a lot. It gives me an overview about busbar testing, about busbar system with less effort, less time for sure. But it doesn't mean that we will cancel the conventional testing by test universe, which also it's important to check the stability, not stability, I'm sorry, the operating characteristic, at least pick up and drop off can be done. Maybe I will return back to the, you like to start with the...
Let us do the test universe directly.
Okay.
Yes, so we can open the module.
Exactly, okay, I will close the relation test software, and I will open the... This is OCC here. Okay, I have the computer is yours. You can now start. Okay, start from scratch. So maybe this object.
Yes. So exactly as you can see here in our OCC file. So the word OCC stands for Omicron Control Center, and in Omicron Control Center we have our Ohm's law, Omicron Ohm's law, which stands for O for the object, H for the hardware module, and M for the module we are going to test. So you need to prepare your test object, and then you need to prepare your hardware configuration and define what exactly you would like to do for testing. So basically, differential protection, we have a three main module or three main tests. The first one was the differential configuration or differential stability against external fault or against heavy load, for example. The second one is differential operating characteristic, where we are testing the slope, where slope 1 or slope 2, for example, if you have differential for transformer with two slopes, or the busbar with a single slope, and the third one is a differential trip time or differential trip characteristic. You want to confirm exactly how long the relay will take to trip. So just to save the time, let us go for the test object. I will double click. And by the way, we don't have in Omicron any testing yet in PTL for a busbar, because we consider it's an open scheme and it is different from a country to country.
Or it's possible to cover all type of schemes in the world wide. It's completely out of control. But you can create your own PTL. You can create your own OCC, like what I did already. These will have can open the test object and show them how to link the X-ray one.
Yes, exactly. Because actually, when the idea behind that, the PTL, that we are getting the global protection function from all over the world, and we are creating a template or creating a file that you can use it in Saudi Arabia, use it in India, Hong Kong, in China, and in the States. So based on that, we are creating that. But for the open scheme like Busbar, we don't have one unified.
It's not something fixed like distance protection, for example.
Exactly, because even it is different from country to country, and inside the same country, two substations, they have two different Busbar schemes. So let's go back to the test object. In the test object, once you will see that you will have here the REB 670 settings, and you can see here we have added some parameters. The first parameter is a V primary, which is the primary voltage, and we have some webinars before regarding how you can script and how you can create a OCC from scratch.
The video, we have a good video in our YouTube channel, in official Omicron YouTube channel. It's called X-ray.
Yes, and how in this you can define exactly what kind of a parameter, how you can link, how you can create. But here, for example, let us see what does it mean. Name, this is an arbitrary name. I can name it a primary. ID, which is a unique name for each parameter. You can see it's never duplicated. Foreign ID, it's an ID for this parameter, which I will be importing.
I will switch off the CMC now for better voice quality.
Exactly. Thanks, Muhammad. So the foreign ID, this is the ID parameter which you will receive it from the relay software. For example, if you are exporting from Siemens Relay DXI5 or DXI4, BCM 600, you can see here, go to File, Import Relay Settings. You will see something we call Import Relay Settings filter. This filter is just a window between the test universe and the relay software. You are exporting from the relay software, importing to the test universe via this filter. It's different based on the relay software itself. So, but every parameter or every relay settings is exported with an ID. This ID we call it, because it comes from outside the test universe, so we call it foreign ID. Description. This is description. What does it mean? This is mean the primary voltage for this substation, for this, for example, Busbar. Reference value. If you have a reference value for your substation, is a 33 kilovolt. The value here, and the value is 400 kilovolts, for example. Then, if you would like to write any kind of information or a formula here in the formula part, you can just, by easy way, just press Control-I. It will give you a link of everything where you would like to link. So, for example, I would like to link to the frequency. So I will go here to device. Then, regarding to the nominal values, if I would link to the frequency, just like that, press Accept. So this value automatically will be linked to the frequency. Whenever I change the frequency,
but this section I make it to be entered manually, and I did the equations in the real block.
Yeah. So this is example if you would like to link anything from up and down. So now let's go to the differential protection, because this is our module. Once you double click the differential protection, so what is our application? We are going to protect the Busbar. So how many bay we have? We have a bay 1 and bay 2. And the rated voltage is a 400 kilovolt, and the power is equal to the square root of 3 multiplied by the V line to line multiplied by CT primary, so it will give you around 2 gigavolt ampere. So this is calculated automatically once you change the rated voltage of 400 kilovolt. If there is a star point grounded, no, because we don't have a grounding point in the Busbar.
The bar would have to enter it manually, but the current is calculated.
Yeah, okay, the current is calculated. Yes, exactly. You need to enter the power, and the current is calculated, so it's a vice versa. If you enter the power, it will be calculated the current and the same.
And also for the protected object, we can select Busbar, motor.
Yes. Here we have 4 types of the protected object we need to protect or we can protect with the same module, transformer, generator, motor, or a bus bar. Line, yes, we can make it a line with that, with a transformer star 0 with a vector group 0. So there is, if you have a transformer 132 kV, 132 kV star 0, and there is no vector group, so it means it's useless. Nothing is available in the network, so it means this is as a line. But our application is a busbar, and since we have a busbar, we are defining here star point grounded, because in transformer, if you have a star winding, and this winding may be it is grounded or not, or maybe, for example, in a special case, the busbar is grounded or not, we don't know, via reactor or by something. So the grounding, it can be yes or no. The current, it will be automatically calculated. It will divide the rated, the apparent power divided by square root of 3 multiplied by 400 will give you around 2,890 ampere. Then we will go to the CT, and in the CT here we need to enter the rated current 3,000 ampere and
CT ratio,
a CT ratio, yeah, 3,000 ampere and 1 ampere for the secondary. And very important thing is toward the busbar or toward the object, because definitely you need to define the CT star point. Is it toward that or that? Because it will give you the directionality of 180-degree difference. If you choose wrong star point or wrong directionality, the forward will be reversed, the reverse will be forward. So it means that, and this is very important to use it with the relay sim test, with the system-based testing, because you are injecting and you will have a different current angles, and based on that you check the stability of your system for a multiple units. Now the protection device. So for example, as we said, the differential equation is unique. So the differential equation is similar in all protection relays. It is the vectorial summation of all current, the absolute value of the vectorial summation of all current, but the strain or the bias equation, you need to get it from the relay manual. Based on our relay manual here, it is the minimum of I primary or I secondary.
It was very big challenge for me because I used to use the bias equation from the line differential.
Which is the maximum.
Thinking it's a similar. No, it's not similar actually.
Yes, for Rep 670, it is the minimum. It is a minimum value of the primary and secondary. What is the primary? What is the secondary? Here you can define. What is the primary and secondary? So based on pay one, so the module will understand that the pay one is the primary side or it is a reference winding. So it will be the minimum of pay one and pay two. If one of them is less than the other, it will take. The factor K, for example, as we said here, if you go to the drop down menu, you will see it is absolute value of primary plus absolute value of secondary over K1, and K1 can be 1 or 2, for example, as in Siemens.
Based on the relay type and
based on the relay type. So we will go to the minimum, I primary, I secondary. No combined characteristic. Here we will not spend a lot of time, but this is related to, especially to ABB relay. In case if you have a single phase differential module or differential operating characteristic, you need to combine all of them to avoid the trip in case of a single phase module. Please refer to our latest webinar about the transformer differential protection, where we will explain more about the no combined characteristic. The maximum trip time here, it is a maximum time that the CMC will wait the trip command to come from the relay. If it is expected to trip, if it and the relay didn't give a trip command for 1.5 seconds since the fault inception, the CMC or the test universe will consider the point fail. Delay time is 0.25 millisecond. It means that if you have a multiple shots in a different location, the CMC will wait for 250 milliseconds between every 2 points to give at least proper time to relay to reset. IDIF greater, which is the minimum operating current.
From the relay setting, yes.
Yes, if this is from
and
the relay.
Important because in the next tab, characteristic definition, when we will go through,
yes,
it will
cut.
really cut.
Yes. So IDIF greater is 0.1 I nominal. This is the minimum operating current. IDIF greater is 0. We don't have it, but here we have an idea. If we would like to extend the line to infinity, yes. So we need to make the IDIF greater. It's a small trick, but it's very reasonable because the people will say, how can I extend the line to infinity? Just to put IDIF greater equal to 0.
If you would like to give, for example, you have, because it's not logic to have a short circuit more than 25 or 20 I nominal.
So you can give a value to cut the characteristics.
Yes.
Current tolerance and time tolerance. This is you need to get it from the relay because you need to see where the relay will accept the tolerance if it is trimming or not. The reference current, we have two types of the reference current. If it is a normal current, nominal current, or for the current transformer nominal. So if you have a transformer, you have two parameters. The first parameter is the CT ratio, or the primary current of the CT. The second parameter is the full load current of the transformer. Based on the relay calculation, what is the reference current? Here in our case, the reference current is the transformer nominal current, which is the 3000. The operating time here it is 0.03, and the operating time for Diff greater 0.03. This is very important, zero sequence elimination, but it is not related to the busbars. It is related mainly for the transformer. If you have an external elimination for the zero sequence component to avoid the mal-operation in case of a single phase fault, or if you have a none, so you are eliminating the zero sequence externally using an interposing CT, or you have a dedicated interposing CT and you need your CMC to inject on the interposing CT, then it will eliminate. Then you need to tell the test universe what kind of an interposing CT. Is it a star delta transformer interposing CT or a star delta star interposing? Then you will go to the characteristic definition. As Ibrahim told us, it's very simple. It is just a line segment, start and stop. So as we said, it is starting from 0 to 0, and the slope of our characteristic is 30. So you need to go to somewhere here, choose any point arbitrary. So Ibrahim, when he created this OCC file, he chose I bias of 5. So then if you try to apply the calculation that I differential equals the slope multiplied by I bias, so it will be 5 multiplied by the slope, which I know from the relay setting, it will be 5 multiplied by 0.3, so the differential current will be 1.5, and automatically it will be.
Honestly, I use the equation. I'll have to be calculated automatically. We will see it later.
Yeah.
Yeah. Only the customer will feed the real block of under the customs.
Yeah. Here.
Yes. Only those data he has to feed.
So for example, let us make it 0.5. The slope is 0.5. I will press 5. Then I will go to differential. What I will see here the differential characteristic definition that the slope is become 0.5, and it is a 5 multiplied by 0.5. This is 2.5.
This is the power of
the scripting and the automation.
Yeah, and this was very easy. By the way, for me it was a challenge because I would like to add something which from scratch it was not exist in the BTL. I want to show customers that it's easy. You can do it by yourself, even if it is not in the.
It's very easy. You can just go to differential, then diff bias, then trip characteristic table, and here, and you will find 0.1. 0.1 is the origin, 0 and 0.
Yes.
We don't have any relation. Then you can even, if you would like to fix it, 0 and 0, just type here 0 and type here 0. This will be automatic, and you can see now it is turned to gray. The color means it is linked to a value.
Yes.
Now you will go to 0.2.
This is the equation.
0.2, the first one is the y, which is the I differential, and the x, which is the I bias. So Ibrahim decided that his characteristic will be 5. So it will be the I diff greater multiplied by the slope. This will be the x characteristic, which is the bias current, and the differential will be the 0.5, which is the characteristic of the I bias multiplied by the slope, so it will be 2.5. To avoid any mistake while we are testing, we need to return the value here to 0.30. Frequency, you need to get it. This is important from your systems. Then we will press.
And sorry, I have the green sign. Please let our customers know that green sign means everything is fine.
Yes, everything is fine and compiled, and there is no scripting issue.
If anything else, then there is an issue. We have to rectify it before starting the test.
Yes, once you are dealing with our BTL and you're trying to import the relay setting, here there is 3 words and 3 numbers. I, it means imported. W mean warning, E mean error. So I import, for example, 500 parameter, and I have 1 warning, but I don't have error, so it means it's fine.
But here, because I'm not using importing, it's a 0.
So say it is 0 and 0 and 0. And since Ibrahim, he did the compiling and everything is fine, so he doesn't have any problem. Let us go to the structure of the OCC file. We finish the object. We will now have the hardware configuration.
Yes.
How many?
This is the new hardware configuration because I'm using the sample value. As you can see, it's a 3.
Yes, we can
but
go
it's
to
not
configure.
our topic today, Ahmed, because of the time. Yeah, please.
We will turn on the CMC.
Yeah, instead of that, they can use normal analog currents. Same. Can you please cancel and use analog output? Here, analog output, you can select how many
From okay, not from here.
Yeah, no, just a minute. Here, as you can see here, number of
okay, from the analog
voltage,
output,
current. Here, for example, if I have 2, I can configure and check
the characteristic.
Exactly, yes. Okay. Here. And here, let's do scan.
Scan, this is to find which CMC is connected to the network. It's powering up.
Yeah. Once it is ready, you have to see here that it's coming with a serial number and all information about the CMC, which is connected to your laptop. This is a new software, as you can see here.
Yeah,
game already. Yes. As you can see, this is a new software testing universe 4.30. I recommended to upgrade to this one. If you need to do the same, can be done with the analog, and you know already analog output, binary input, binary output. If you would like to,
yeah, we can just say for analog output, we will not talk about it because it's already from the sample value. But here, if I would like to have a wet contact or a dry contact, if you can see it is here tech, it means it's a potential free. If I would like to make it wet, just I will remove it, enter the value of the rated voltage of my switchgear or substation, then it will be multiplied by 0.7% to calculate the threshold to avoid any operation in case we have an earth fault in the DC system. Afterward, we can just here we will cancel this and we will go.
We didn't change it.
We didn't change, so yeah, we will save. Okay, now we'll go to the boost configuration.
Yeah, this is to assign the feedback coming from there. It's also maybe it's not our topic for the
yeah. We will open it like just to apply a configuration.
Yes,
that it's already
automatically
applied.
It will be done by.
And then I applied already the configuration. I import the SCD file from the relay, drag and drop everything.
For the analog, sorry, I have to interrupt you, but for the analog system, you don't need this at all. Only current to be configured, 6 output connected one feeder one to the same file, by the way, and you will inject the analog current instead of sample value. Then I put here maybe yes, this image from the relay manual to show you that the testing file itself, you can add some helpful information, like also boost module if you would like to add the boost module, how to connect or warning or something. And after that, you can talk about the advanced differential test module like configuration, like.
Yeah, we have here the configuration module where we can just double click
to check the stability.
We can run all of them automatically, but let us see exactly what we have. Here we have a transformer star 0. This is, as we said, it is meaningless because we have a transformer star 0 with the same. It's like a busbar. Without nothing to change in the transformer. Here I need to test at 1 I bias to confirm that my system is stable. And once I need that, I can just press and continue.
Then no trip will come from the relay.
Then I'm injecting, and as you can see, this green, it means it is synchronized to the PTP switch, so it is everything is fine. Afterward,
if you are using one single CMC, you don't need this.
You don't need this, exactly. Now, since there is no trip come from the relay, I can just press pass.
But I would like to have to tell them about the data, the test.
Now you can see here, I have a fault on this side, on the load side. Now let us, someone, he said, no, I need the fault outside in this direction to confirm that my system is stable. What I will do is just I will clear, go to the test tab, to the general tab. In the general tab, I have the fault at bay 1, supply at bay 2, or I can just change. If I change this one, you will see that the supply is in bay 2 and the fault is in bay.
External means stable.
And the other side, and it will remain stable because the fault is outside the protected zone, outside the CTs.
Go back again. I have test.
Then I will go to test data. For the test
here, you need to enter the value. Really, if you will start now. We need to ask our customers to put this because it will be documented. Start.
Yeah. Now I press start, and once I press start, you can go back to the relay, get the value of the I differential and the I bias for the 2 bays, and then you can record it here. For example, differential should be 0. The bias, since I'm doing single phase L1E, so it will be here 1, and the other will be 0. So differential current will be 0, and the bias current should be 1. Once I'm done, I need to press pass. Once I press pass, the test will stop, and you will see here in the test data it is lost. If you would like to have any binary output condition, for example, you would like to simulate carrier receive, carrier send, give indication to the HMI, so you can just wire up any binary output from the CMC to the relay. In the general tab, there is so many parameters we can talk about it. The trigger condition, for example, if you want to confirm that bay 1 trip and bay 2 trip and the check zone trip, so you can extend the 3 wires from bay 1, bay 2, and check zone, and you combine all of them here under the AND gate, and this will work fine. Now, let us say the time trigger. Time trigger, for example, here, if I would like to simulate with a different 2 CMCs, not with a 1 CMC, I need to simulate and synchronize all of them together. Then I can apply time trigger bay 1, bay 2, and the tertiary. Voltage applied. If I would like to simulate a voltage on a certain bay or a certain bay unit, then I will just remove this one here, tick. So it will apply voltage in bay 1 or bay 2. Which one has a voltage signal? Now, let's go back to this. Same for L1, L2, nothing changed. Just I change the fault loop. And where can I change the fault loop? I can change the fault type from here. L1E to L12 to L1, L3. Now, let us go to the next one, which is the differential characteristic for a single phase. In the differential characteristic single phase, as we said, it's very, very simple. We have the minimum operating current, and we have a slope of 0.3. And we have, first one is a short test, where you can select fault in everywhere. And as we said, the tripping area is between the blue slope and the hashed slope, which is the maximum operating. The maximum operating torque line is the line with an angle 45 degrees. But some of the people will say it's not, it doesn't look like a 45 degree, it looks like 60 or 70. We will say that you can look at here, and you will see that the scale of the x-axis is different from the scale of the y-axis. So both of them, if you calculate any x and any value of y, you will see it is here 0.5, and it is here also almost 0.5, so it's a 45 degree. Here it is a blocking characteristic region, the blocking area, and here you can simulate any fault because it is not applicable in the power system. In the general, you can have many parameters. The first parameter is ignore nominal characteristic. If you are testing a differential relay or a busbar and you don't know exactly what is the slope, maybe 0.3, 0.5, so you will draw any arbitrary slope and ignore the normal characteristic, and you will have a search line, and the search line will ignore this slope, and it will try to find you the actual slope. This is
we have to remove it.
Yes, but we need to remove it. But since we have it, we will.
No, remove it. Remove it. It should work.
Okay. So let us go apply for the pre-fault. How long is the pre-fault you have, and how long for the pre-fault time. So for example, if you would like to simulate a normal condition with 1 ampere for 1 second, enter the value here for the I nominal and I second. The voltage output, as we said, whenever if you would like to attach a voltage or inject a voltage during the injection, so if it is in a bay 1 or a bay 2. Time synchronization, trigger is a bay 1 or a bay 2, or the trigger condition, as we said, you can have it from zone 1, zone 2, or bus 1, bus 2, and check zone. Binary output, if you would like to extend anything, as we said in the different configuration. Let us go to the search. Search, you will see different values at a different bias current, and automatically, based on the slope, if we have a 0.2, then you will define on the I differential, which is here, in the slope 0, so the minimum operating current should be equal to the differential I diff greater, which is 0.1. But behind the knee point, if for example have a 1.2, so if you define 1.2 divided by the relay slope, so it will give you the I diff 0.36. 2.2 divided by slope, it will be 6.6. Fault type here is L1, L2. Resolution, that if how long the CMC or the test universe will move between two different points. Now, for the time sake, let us start. You can't hear anything because it's not injecting.
It's injecting sample value.
It's injecting sample value.
This is a new feature with the new software, with a new version. Because before we have to generate analog at the same time with the sample values.
Yes, exactly.
Now we can publish 3 streams.
And yes, and you can see binary input 1 is triggering. It means that there is a trip command.
Maybe they can see it in the trip time.
Yes,
which is coming up.
Now you can see here the expected 1, high nominal, it becomes 0.097. Now it is 0.36, so it is 0.356, so, and it is within the tolerance, so it is fast. Now it is testing the third point.
And how we are testing now, we are injecting in 2 feeder, one reference, B1 and B2.
Yes, exactly.
And you have to repeat this between 2 and 3, 3 and 4, and all of that, because that will take longer time. But with relation test, one time you can inject all if you have enough number of CMCs to cover all feeders.
So we can stop
as you like.
Now,
time.
yes, because we
5 minutes.
We have 5 minutes. Yes, then we will go to the diff trip characteristic for example, L1, L2, L3. It is similar as a transformer differential. We have the minimum operating time, which is 0, and we have the maximum operating time, which is around 60 milliseconds.
I think 60 actually, it should be less, but you will find the time is very.
Then you can just add any point if you would like to have any number of points here, and you can just see exactly how much the current will see. So this is the minimum operating, this is the operating area, and with the fault loop is L1, L2. Generals and factor, it is similar to what we talk about it. Then let us start. Now we can see it's around 9 milliseconds.
Yes,
which is very fast.
I put here 60 to be honest, so it's more than the tolerance of the relay.
And I think this is for the test universe part. And I hope, Aditya, if you have any question, we will be happy to answer it.
Yeah, to answer it.
Thanks, Aditya. I will give you the presenter mode.
I think you can keep it with you for time being.
Okay.
Because there are some questions for which you may want to share your screen. So thank you very much, Ibrahim. Thank you very much, Ahmed. There are a couple of questions.
Yes, please.
Yes, Aditya, go ahead.
Give me. Yeah. One gentleman, Mr. Shiban, is asking few questions which are related to what we are discussing here. So I would request Mr. Shiban to unmute yourself and ask your question. Let me remove the link lock from here. So you can now unmute yourself and ask your questions directly.
Okay,
go ahead.
Okay, thank you very much, moderator, Mr. Ibrahim and Mr. Ahmed, for your presentation.
Thank you.
I hope you are hearing me.
Yes,
yes,
hear you.
yes.
Okay, for the case of relay sim test, is it possible to